Okay, so this lesson, this is for Math 9s. We are going to be looking at algebra tiles today, but just to refresh from last class, let's take a look at this question here. So we have 3 brackets here. Let's work with our first bracket. We have a 4 in front of it, and inside we have x squared minus 1. So we do have to multiply that 4 with everything inside that bracket. So 4 needs to multiply with x squared, and it needs to multiply with the negative 1. So multiplying that out, we get 4x squared, and then 4 times negative 1, that's negative 4. 4 minus 4. All right, so that's our first bracket. Next, we have the negative in front of our second bracket. So recall that that negative or this minus changes the sign of everything inside that second bracket. So this will become now minus or negative 2x squared and then plus 3x. And our last bracket is just plus 7x squared plus 6x. So we don't have anything to do in front of that bracket. We just have to open up our bracket. So plus 7x squared plus 6x. Okay, and once we are at this point, we are going to collect our like terms. So recall all your like terms, they have to have the same variable and the same exponent. So we can collect here the 4x squared, collect it with the negative 2x squared with the plus 7x squared. All right. You can always use your calculator so you don't mess up with the integers. So it's 4 minus 2 plus 7. I just put that in my calculator and I got 9. So that one is 9x squared. Next, I will collect the variables with x. So we have a 3x here, and we have a 6x, positive 6x. So positive 3x and a positive 6x. Collect those together, and I get 9x. And our last one that's left is just a negative 4. There's nothing else here to collect that with, so we would just bring down that minus 4 like that. All right, notice again, when I put my answer here, I've done it in descending order of our exponents. So x to the power of 2, then we have x to the power of 1, and then our constant with no variable. So basically x to the power of 0. All right, so that was a quick recap on adding and subtracting polynomials. And today's lesson, we are looking at algebra tiles. So I'm just going to put up here the algebra tile legend and what they represent. You will get this legend in your modules as well, so that you can always refer back to it. So when we look at algebra tiles, we have ones that are shaded, like so, and the other ones that are unshaded, like so. So anytime you see shaded, shaded is positive, and then unshaded is negative. And then you're going to see three types of tiles. You're going to see a tiny little one like this, and if it is shaded, that means it represents a positive 1. You're going to see a longer rectangular shape like this, And if it is shaded, that means it is a positive x. And the last one is a larger square like so. And shaded, it means it is x squared. And again, positive. So positive 1, positive x, and positive x squared. If you saw those same tiles unshaded, then it would represent negative 1, negative x, and negative x squared. I'm just going to show that as well. All right, so if we have an unshaded little square, that represents negative 1. And if we have an unshaded rectangular like so, that represents negative x. And if we have an unshaded larger square like this, that is a negative x squared. Okay, so what does this mean? And how are we going to use these tiles? So let's take a look at our first example. All right, so first example, use algebra tiles to represent the expression 2x squared minus 3x and then plus 4. All right, so this is our polynomial expression. It's actually a trinomial. There's 3 terms. And we have to express this, use algebra tiles. So we have 2x squared, meaning positive. Okay, it is positive because there's no other symbol in front of that 2x squared. So we are going to put down 2 of the large tiles, but make sure we shade them because shaded means positive. All right, next we have negative 3x. That means we have to put 3 negative tiles that represent x, so those rectangular ones, and we have to make sure we don't shade those in because unshaded represents the negative. And lastly, we have a positive 4. So we have to add those little squares to represent that positive 4. And we have to make sure we shade those in because positive 4 is represented by the shaded tiles. All right, so now if you didn't have this equation, if I just hide it like this, and you just looked at the algebra tiles, you would know that there's 2 positive x squared tiles, there's 3 negative x tiles, and there's 4 positive 1 tiles. All right, let's take a look at the next example. I'm just going to pause it here actually. Okay, so our next example here, we are given the tiles. So here are our tiles. We have a positive x squared, a negative x squared, a positive x squared. Then we have positive x, negative x, negative x, negative x, plus 1, a minus 1, plus 1, plus 1. Okay, so the first method you can use here is write out what each tile represents. All right, so we would have an x squared minus x squared, a plus x squared, and then we have plus x, and then minus x, minus x, minus x, and then we have a plus 1, minus 1, plus 1, plus 1. So you can write it out like this, and then you can collect your like terms. So here it would be x squared minus x squared plus x squared, which will leave you with x squared. And then here we have x plus x minus x minus x minus x. So you can collect those like terms. just lost my marker. 1 second. So you can collect those. Which will give us negative x, or just minus x. And then we can collect our last ones there. 1 minus 1, plus 1, and then plus 1, which gives us plus 2. All right, so that's the one method you can use, is write them all out and then figure out the equation. The other method you could use here is by canceling out tiles. So if you have a plus and a negative, same tile, those are going to cancel out because a positive and negative cancel out and you get 0. So positive and negative, that cancels out, and we're just left with a positive x squared. Then we have 5 of the x tiles. So again, a positive is going to cancel out with a negative. And this positive is going to cancel out with this negative. And you're just left with a negative x. And then we'll look at our little squares. So again, plus 1 minus 1 is 0. So we'll cancel that out. And then we're left with a plus 1 plus 1, which is equal to 2. All right, so same result both ways. I just find it is easier to just cancel out the positive and negatives and then just write down what you're left with. Okay, so we're just going to take a look at this example here. So I'm just going to show what each tile represents. So again, here was our legend of the algebra tiles. Anything shaded is positive, anything unshaded is negative. The little squares represent 1. If it's shaded, it's a plus 1. If it's unshaded, it's negative 1. The rectangles represent the x. And again, if it's shaded, it's a positive x. If it's unshaded like this, it would be a negative x. And the little squares like this, if they are unshaded, they represent plus 1. And a shaded one, sorry, the unshaded represents negatives, so negative 1 and negative 1. And the shaded little squares represent a plus 1. Okay, so let's just write out here what each tile represents. So this would be a negative x. This would be a positive x squared. Then we have a minus 1 and a minus 1. Then we have a plus x. And then we have a plus x squared. Then this little guy, this one is a plus 1. And the last rectangular one, that's a minus x. All right, so once you've done that and you've written that all out, you can collect your like terms if this is the method you choose to do. So we have a plus x squared and a plus x squared. So 1 plus 1, that gives me 2x squared. Next, I'll work with the x values. I have minus x, a plus x, and a minus x. That will leave me with just minus x, or minus 1x. And the last one is negative 1 minus 1 plus 1. And that leaves me with just minus 1. So our expression here, once simplified, is just 2x squared minus x minus 1. The other method I showed was crossing out your positive and negative tiles. You'll still get the same answer. So we'll start with our x squareds. It's a positive and a positive, so we can't cross anything out there because plus 1 and a plus 1 x squared gives me 2x squared. So for that, we still end up with just 2x squared. Next, we'll look at our x tiles. So we have a negative here and a positive here. So negative x and a positive x, that just becomes 0. And we're left with 1 negative x. And then we have our little squares. So we have a -1 and a +1 that cancel each other out. And we're just left with a -1.